Welcome to SanfordFlipMath, the home edition. We are deep into the quadratics unit. We've spent a lot of time factoring and then a lot of time solving, and now it's time to start looking at graphs. When we started venturing away from linear equations like y equals mx plus b, we spent a little bit of time looking at just numerically, looking how the rate of change is different as you go down the list for what ultimately became quadratics. And we even looked at a little bit of graphing and seeing the parabolic shape, the parabola shape, the U shape of things with x squared involved. Well, now we're going to kind of nail down some details. So buckle up. Here we go. So this is the idea here is graphing something that is in this form, the y equals ax squared plus bx plus c. This is considered standard form. Sometimes it's called general form, and different books don't agree on these things, but it's okay. It's not a big deal. And what I mean by that is it's ax squared plus bx plus c. It's a number x squared. Maybe there's no number here. It's just one x squared, and a number with x and a number without x. The things that we're going to hit here is specifically is shape, and we'll see in just a second that these graphs look like a U shape. They could be located in a different spot on the graph, but they always have that U kind of shape, which is called a parabola. Okay, parabola. It's not a parabola. It's not a pair of bowls, as it were. We will see that it has symmetry. Symmetry basically means balance. You can picture a line going right through the middle of this thing, and it's like a mirror image on each side of it. So there's the side that goes like this and like this, or for this one, it's this and this. And we'll see that. We're going to look at a specific example in a hot second. We're going to talk about how to find the x-intercepts. Remember, x-intercepts are where it crosses the x-axis. And so if it's crossing the x-axis, then it's on the x-axis. The y values are 0. And we actually already know how to do that part. Conversely, the y-intercept is going to be 0 something, because that's where it touches the y-axis. We're also going to talk about how to find a mirror point for the y-intercept using symmetry, just to give us another point to work from. So as we're graphing parabolas, our goal is to have 5 points to graph it. And it's basically going to be, unless there are some points that are in common, it's going to be the vertex, it's going to be the x-intercepts, it's going to be the y-intercept, and its mirror point. Okay, so 1, 2, 3, 4, 5 points are what we're going to be shooting for as we do this, and we'll just kind of see how it goes. Okay, all right. So we're going to start by just literally looking at points and tracking them through, and then we're going to get a little more strategic. Okay, so I'm just going to plug in numbers. Just a reminder that solutions are values that make the equation true, and a graph is a picture of the solutions. Okay, so what we're going to do is find some values that make it true. We're going to put them on a graph and make a picture out of them. Okay, so that's what we're going to do. So we're going to just put in -2. Well, -2 squared is 4. Minus 4 times -2. Well, 4 times -2 is going to be -8, so it's really going to be +8 minus 5. So this becomes 12 minus 5, or 7. I'm going to plug in -1. -1 squared is 1. Minus 4 times -1, so minus a -4, so +4 minus 5, that ends up being 0. Well, that's cool. I'm going to put in 0. Well, 0 squared is 0. Minus 4 times 0, minus 5, so -5. I'm going to pick up the pace a little bit here, but again, all I'm doing is substituting values here. Okay, so this becomes 1 minus 4 minus 5, so that's 1 minus 9, so -8. Is that for real? 1 minus 4 times 1 is 4. That's so much for picking up the pace, right? Just wanted to make sure that that was right. 2 squared is 4. Minus 8 minus 5. So this is -9. 3 squared is 9. Minus 12 minus 5. So this is -3, -8. I'm going to put in 4, so 4 squared is 16, minus 4 times 4 is 16, minus 5. 16 minus 16 minus 5, so that's -5. All right, so let's do some graphage. Ooh, this was not a good setup for this guy, is it? So I was thinking all of these were numbering by ones, but I'm looking at these points going down to the negatives, and that's going to be awkward. So, oh well, we'll just wing it. We'll see how it goes. Maybe I'll number it. So this is 2 fourths. I'm going to number by 2s. Okay, so that I can get closer to what I need without making a mess. So this will be -8. This will be -10. And I'm going to go ahead and I'm going to stay numbered by ones here. So I don't want to confuse you, but that is what's going on. Okay, so -2, 1, 2, 7. So 2, 4, 6, 7. -1, 0. 0, -5. 1, -8. 3, I'm sorry, 2, -9. Yeah, about there. -8, and then -5. Okay, so I need to see enough graph so we can see that turn. If it's squared, then we expect to see the parabola shape, the U shape. And I need you to see how it came down and then went back up. It's starting to go back up. So this is clearly not linear. And then if I keep going, let's go. I'm just going to keep going a little bit more because I want to see where it crosses the x-axis. Sorry, I started to draw my curve, but then I got distracted. All right, so this is 5 squared, so 25 minus 4 times 5 minus 5. There we go. That's what I wanted to see. So 5, 0. So where am I at? 4, -5. Oh, I'm not going far enough here. Well, this is awkward. There we go. I feel better about this now. This would be much nicer if we had a grid, but I'm not at school, so I don't have a pile of graph paper just laying around, and I'm too cheap to print it all out. Sorry. So some things to note here. Do you see the balance in this? And I know it's not graphed perfectly, but I need you to see the balance. Do you see how it's balanced around this point in the middle? This point in the middle has a name. It's called the vertex. So that point's called the vertex. It's always going to be the low point or the high point of the graph, and everything is going to be balanced around it. In this case, that vertex was at 2, -9. So that's how we name the vertex. We give it an ordered pair. There is also a line that establishes the symmetry. It's in effect where the mirror would be if we were talking about the balance. So, and it always goes right through the vertex. So this line is called the axis of symmetry. And the idea is that if I go 2 to the left of that line, that axis, notice my y value was -5. If I go 2 to the right, notice my y value is -5. If I go 3 to the left from the 2, notice my y value was 0. If I go 3 to the right from that, it's also my y value is 0. So the idea is if I go equally left and right, whatever is going on there will be the same for the y value. The y values will be the same on the left and right side of that. So how do we say the axis of symmetry? Well, it's a line. It's a vertical line. So it's x equals, and it's literally just the x value for the vertex. Okay. Also note the y-intercept. These are all things that I'm going to be looking for. The y-intercept happened to be 0, -5. Now, I don't know if you remember this from when we were graphing before, but notice how this point right here, that -5, is the y-intercept because the x value is 0. So the things with x just go away, and whatever's left becomes the y-intercept. Okay. The x-intercepts are where y equals 0. And where y equals 0, it's literally where you could substitute 0 in here, and we could even write x squared minus 4x minus 5 equals 0 and solve this for the x values. And this is literally what we're going to be doing. So x equals 5 or x equals -1 as we set each of these factors equal to 0 and solve. Okay, so this is part of what process we're going to be using to do this, because we don't want to be graphing all these points every time, just hitting, taking guess, which points do you graph? I don't know, right? So, you keep graphing until you see the turn, until you see the vertex. Well, we don't want to do that, okay? All right, so some big takeaways from what we just did was literally this is just a picture of the solutions. We found some solutions and we drew them, okay? Identifying some terminology, some vocab here. The vertex is that low point or the high point. It is the place where the graph literally turns. It is the place where the symmetry is based. So line of symmetry down the middle, and that axis of symmetry for us, it's always going to be x equals the x value of the vertex. Later on in pre-calculus, maybe in Algebra 2, you'll do some parabolas that open sideways and it'll be y equals, but that's not going to be us. We're just going to be doing x equals the x value. We will also find the y-intercept, and we'll also find the x-intercepts. Okay, so let's do another example. This was really to lay groundwork. Now we're going to hit it in the order, in the process, in the strategy that we're going to use from here on out. All right, so we have a new problem, a new equation, and I'm going to lead you through the way we're going to go with this. So the first thing we're going to do is find the x-intercepts. Sometimes the x-intercepts are referred to as zeros. Sometimes they're called solutions. Sometimes they're called roots. These are all synonyms. So roots, zeros, and solutions all basically relate to each other depending on context. Okay, so what we're going to do is find the x-intercepts, and again, they're called zeros because they are the x values that make y 0. So remember, x-intercepts are going to be x equals something, y equals 0. So I'm just going to substitute 0 in here for y. Now, to solve this, and this is the thing that we've been doing now for the last couple weeks, is solving this kind of an equation. I'm going to solve it by factoring. I know this happens to factor, so I'm not worried about doing quadratic formula. We'll do that on the next video, kind of. So let's go with this. Now we already have equals 0. Is there a greatest common factor that we can take out? 2. Now I'm going to take out the negative, and the reason is I hate factoring when the x squared term is negative. So I'm going to take out -2. So even if there wasn't a negative in common all the way through, if this was a negative, I would always take out the negative, always. X squared. Now I took out the negative and the 2. So this is going to be plus 2x, and then this is going to be what, -3 now. It's -3 because I took out a negative. 6 divided by -2 is -3. Now this all equals 0. Okay, and I know my work is kind of funky because I left room for the graph and I didn't leave enough room for this work, sorry. So -2, and we're going to factor some more. I know the signs are different, so it's going to be x plus, x minus, or you can write x minus, x plus if you wish. Factors of 3, it's just 1 times 3 or 3 times 1. I mean, that's not very exciting. And they have to add up to +2. So the bigger one is going to be the positive, and the smaller one is going to be the negative. Set each factor equals 0. Well, -2 never equals 0. X plus 3 could be 0, so x equals -3. X minus 1 could equal 0, so x equals 1. So those are my x-intercepts. -3, 0, and 1, 0. Those are my x-intercepts. Okay, so you need to be able to find those. So 1, 2, 3, and 1. Now remember that this graph has symmetry. It's balanced. So the axis of symmetry has to be right down the middle of these. So we're going to use these points to find the axis of symmetry. So my question to you is, what number is halfway between -3 and 1? What number is halfway between negative? Well, you can literally count squares on this because we're on a nice little graph here. 1, 2, 3, 4 squares to get from -3 to 1. So I guess halfway would be 2. So 2 in from either side, and boom, chakalaka, there we are. Where am I? I'm at x equals -1. Now, another way to do that would be to average. So I could do -3 plus 1 divided by 2, and this will find the axis of symmetry. So -3 plus 1 is -2, divided by 2 is -1. Okay, so that's another way to find the axis of symmetry, but basically you are finding the value halfway between the two zeros. So the vertex has to be at -1 comma something, because remember the vertex, the high point or the low point, the turn point, it has to be on the axis of symmetry. So what we've just done is kind of a backwards way to find where the vertex is. We found the x-intercepts. We figured out the x value halfway between them. That's the axis of symmetry. We're going to use the axis of symmetry then to find the rest of the vertex, which is just the y value. So I'm going to do -2 times -1 squared minus 4 times -1 plus 6. Be really careful with signs here. So this is 1. 1 times -2, so -2 plus 4, because it's minus a negative, plus 6. So this is 10 minus 2, 8. So the vertex is at -1, 8. 1, 2, 3, 4, 5, 6, 7, 8. So right there. Okay, so we're going to find 2 more points, and then we're going to just sketch the graph, and we're going to be done with this. Okay, so this is what I'm looking for you to be able to do. Find the x-intercepts, which involves solving just like we've just been solving. So x-intercepts are when y equals 0. Solve the equation, factor, set each factor equal to 0. Find the x-intercepts. The axis of symmetry is halfway between those 2 points. So you can either eyeball it off the graph, or you can actually average them. So add them up and divide by 2. That's the axis of symmetry. So that actually gives you the x value for the vertex. Now we know the y value for the vertex. All right, y-intercept, easy. It's 0 comma something. Well, if I put 0 in here, 0 squared, that whole term's gone. If I put 0 here, 4 times, that's gone. So it's literally just 6. Now the mirror point, no, so 0, 6, 1, 2, 3, 4, 5, 6. The mirror point to this is, so notice how this is 1 spot to the right of the axis of symmetry. So I'm going to go 1 spot to the left of the axis of symmetry. So this now gives me my 5th point. It'll be at -2, 6, the same y value, the same y value, but the x value on the other side of the axis of symmetry. So now I have 1, 2, 3, 4, 5 points. I'm going to use that to sketch my graph. Okay, so here comes my graph. And you just eyeball where the points are. Don't get out a ruler for this. It's not straight. It's a curve. And alakazam, we're done. Okay, so again, what we're doing is we're finding the zeros, which are the x-intercepts. Sorry, I keep using zeros. That's more of an Algebra 2 word, pre-calc word, but it gets used a lot. So the x values that make y 0, that's what a 0 of a function is. Find the x-intercepts. Average them or find the point halfway between them, excuse me, and then that'll give you the axis of symmetry. Use that x value then to find the y value for the parabola. That is the vertex for the parabola, the corner, the round point, the turn point. Put in 0 for x to get the y value that is the y-intercept, and then kind of mirror that across the axis of symmetry, and that gets you a mirror point, and that gives you 5 points to sketch this curve. We want 5 points. Okay, because that captures the curvature pretty good. All right, so this is the whole process. I want to do one more example just to kind of lock it in, but I know this video is starting to get a little long, so if you need to bail, bail. But again, for if this all seemed like a crazy jumble, then we're going to do one more. Same process. We're going to find the x-intercepts. So I want y to be 0. It's going to be something 0. Plan on 2 of them. It's possible that the vertex is on the x-axis and there's only 1. That's possible, but right now it's not going to happen very often. All right, so I'm going to put in 0 for y. So I'm going to say 0 equals 3x squared. Okay, and now it's already equal to 0. So I'm going to factor. So is there a common factor to take out? I see a 3 in there. 3 goes into that. So 3 goes into all of these. So x squared minus 8x plus 15. I'm going to move the equal 0 over there. I just like it better on the other side. Okay, so the factors have the same sign. They have to have negative, so it's going to be x minus x minus. Factors of 15 that add up to 8. Well, they're the same sign, so they literally do add. So 1 times 15 it adds up to 16. That's not it. 3 times 5. Yep, it's 3 times 5. Okay, so 3 never equals 0, but x minus 3 could equal 0. Add 3 to both sides. x minus 5 could equal 0. Add 5 to both sides. So my intercepts, my x-intercepts are 3 and 5. Okay, so 1, 2, 3, 0, and 5, 0. There they are. Okay, the axis of symmetry is halfway between them because it's balanced around them. Well, what number is halfway between 3 and 5? I agree. So that is the x value now for the vertex. So we're going to put 4 into this guy right here. So 3 times 4 squared minus 24 times 4 plus 45. Okay, well, 4 squared is 16. 16 times 3 is 48. Minus, well, 24 times 4 is almost 25 times 4. 25 times 4 would be 100, so this is 96 plus 45. Well, if I add 48 and 45, that is 93 minus 96, so negative 3. So the vertex is at 4, negative 3. Okay, there it is. Very exciting. The y-intercept, easy peasy to get, is 45. So 0, 45. Well, I'm probably not going to number all the way up to 45. 1, 2, 3, 4, 5. Yeah, that's just not even right. Okay, so the mirror point would be, now if that's at 0, 45, that is 1, 2, 3, 4 to the left. So 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5, 6, 7, 8. 45, and there are other ways to get there, would be that mirror of the y-intercept. Okay, I'm not going to bother graphing those. I really want 5 points, but I'm just going to call it good enough because 45 is ridiculous. I could put in 2, and I could put in 6, and they would give me the same y value, and that would be a good way to get an extra point on each side. But we're going to call it good. Okay. All right. So this doesn't take too long once you know what you're doing. Okay, so I'm going to recap it one more time. And I know, Sanford, you repeated yourself 17,000 times. I get it, but we're establishing a process here. Okay, so first thing we're going to do, notice it's an x squared, so it's going to be a parabola. Parabola, we want the vertex. To get the vertex, we're going to get the x-intercepts. So substitute 0 in for y, solve it. That's what all this was. Okay. To get the axis of symmetry, we want the point halfway between these 2 points. Well, one way to get that would be 3 plus 5 over 2, average those 2 values. That's a way to get a value in the middle between 2 values. So this would be 8 over 2 is 4. Or if you can just eyeball, oh, well, between 3 and 5, oh yeah, duh, 4, okay. Okay, then you're going to use that value to find the rest of the vertex. This is the x value for the vertex. Substitute that into the equation, and then you find a y value, and you're good to go. Okay, so that's the vertex. It also 2 extra points, so you're well on your way. We're always going to find the y-intercept because it's an easy point to find, and the mirror point's usually pretty easy too because you just count on the other side of the axis of symmetry from the y-intercept. Okay. All right, that's it. We're graphing parabolas. We're describing parabolas. So we're describing them with the x-intercept. So this is the kind of thing that I'm very, very likely to be asking on a test or a quiz or something about this. All right, well, that is all that I'm going to talk about this time. It was great hanging out with you. Hanging out with you? I don't know. I feel like I'm there with you now. All right, and much love to you, and we'll see you in class. SanfordFlipMath, I'm out of here. Bye.